This is, I think, question 30. One of the ones you sent me. So it says, as shown below, above, classic deck of cards made with 52 cards, 26 are black, 26 are red. Each color, you get how it works. It says, if you randomly select a card, what's the probability that it will be a diamond or a heart? So when you see OR, you have to use the OR formula. Probability of a diamond or a heart. Just going to draw the little symbols. That's going to be the probability of a diamond plus the probability of a heart minus the probability of both. So what is the probability of getting a diamond? Well, there's 52 cards. And how many are diamonds? This entire bottom row. It's 13 cards. So there's 13 out of 52. Look at your answer. This should be correct. A diamond or a heart. Hold on one second. I just noticed, so okay, your answer is absolutely correct. 26 out of 52. Except that the website wants a reduced fraction. They wanted you to write 1/2. Like, I would catch that when I graded it, but that's why they marked it wrong, is because you didn't reduce it to 1/2. Okay. So if you have your TI-30X or your TI-84, make sure you use the math enter, because apparently they only want the reduced fraction of your answer. Let's see here. A number smaller than 6. So we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have 20. There's 5 in each suit, 20 of them. Not 24. So this would be 20 out of 52, which would be 10 out of 26, which would be 5 out of 13, I believe. Oops. Okay, so just make sure you reduce it. That's why I got marked wrong, I think. Okay. Let's go back to this one. It's the hacker trying to guess someone's password. The hacker knows the password is 8 characters long, and each character is either a lowercase letter, an uppercase letter, or a numerical digit. Assume the hacker makes random guesses. What's the probability the hacker guesses the password on his first try? So we'll just say guess first try. Well, how many guesses could he make? How many different ways could he guess this password? Well, it's 8 characters long. Write them right here. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 characters long. How many characters do we have for the first possible thing in the password? Well, it could be any one of the lowercase letters. There's 26 of those. Any one of the uppercase letters. There's 26 of those. Or any digit. There's 10 of those. So the choice he has for the first character is 26 plus 26 plus 10. 26 plus 26 is 52. Plus 10 is 62 characters you can choose from. Lowercase a, b, c, all the way to z. Uppercase a, b, c, all the way to z. And then 0 through 9. So 26, 26, and 10 is 52. How many choices do you have for the second character? Well, the same thing. It mentions something about repetition. So there's 62 ways you can pick the second character and the third character, and so on. So the number of ways this thing can be input is 62 times 62 times 62 for the number of spaces we have, which is 62 to the 8th power. Okay. Now, that's a huge number. I'll show you right now. 62 to the 8th power. All right. That's huge. That's 2 with 14 zeros after. Okay. So, what's the chance he gets it right on the first try? It's going to be 1 over that. Okay. So it says, what's the probability the hacker gets it correctly? Answer your answer is a decimal or a fraction, not a percentage. You probably could do this if you entered it correctly. I don't know if you could enter this the way it's written. This is going to be 13 zeros and a 2. I would say try and enter this. I'm going to check to see what they have. Let's see here. That was question 34, no, 30, 35. So they have it written as, okay, as the scientific notation. So I guess that's what you can do. I will check that. You won't have an ugly answer like that in the quizzes or the problem sets, okay? I promise you. I apologize if you had one of those in the practice problems. But yeah, it's an ugly number. And you won't have that. So what they want you to do is, I guess apparently is say there's 62 to the 8th power. So we'll do that again. And the probability of us getting it right is 1 divided by that. And that's where you get your answer. 4.5800 to 15. Okay. And the last one method of a procedure called accepting the sampling. Sample weight is selected without replacement. When the entire batch is rejected, there's at least one defective unit. Okay. So what this problem says, with one method of procedure called accepting sampling, a sample of items is randomly selected without replacement. The entire batch is rejected. There's at least one defective unit, at least one. So as soon as you see that, at least one, you kind of know you're going to use the complement. You figure out what's the probability that none were selected. Okay, so the ABCD Electronics Company just manufactured 6,000 rewritten CDs, 180 are defective. If 4 of these are selected at random, what's the chance that the entire batch is rejected? So let's just say, instead of saying let's find the probability of at least one, we'll say, let's do, instead of greater than or equal to 1, let's find the probability of none and we'll subtract that from 1. So we'll do, 1 minus that. So let's find the probability of none. What's the probability that no bad seeds were selected out of the 4? Well, what's the chances of picking a good CD on the first pick? 180 are bad, 6,000 are in total. So the good ones are 6,000 minus 180. So there's 5,820 good CDs. 5,820 good CDs out of 6,000. So I pick one. I get a good CD. Okay. Now what's the chance I get a second good CD? Well, I picked a good CD in the first try, so we're going to subtract 1 from both of these. 5,819 over 5,999. I pick another good CD, 5,818 over 5,998. And then 5,817 over 5,997. So when you multiply these together, you'll get the probability of picking no bad CDs, no rejections. So to get the probability of picking 1 or more, you're going to do 1 minus this answer. This answer is, I believe, 84 something. So let me pause this and I'll plug it in. So I just did it, and this is 0.88527. So that's the probability of getting no bad CDs. No bad, CDs. So that's this number right here. So the probability of getting rejected is the probability of getting 1 or more. So it's 1 minus 0.88527. So we'll do 1 minus that, which is 0.1147, or 11